Hi, class. This is Dr. Condor, and I just want to talk about using your calculator with some basic arithmetic operations. And I want to pull up the syllabus addendum first. And you can kind of ignore these dates over here for now. I have different sections. I have different lengths of term. 6 weeks, 12 weeks, A and B, and so on. And so this is for everybody. When you look at your syllabus addendum, your dates may be different than these that are listed, and that's okay. That has nothing to do with what I want to talk about. Everybody's getting the same information. So again, um, these dates are for the summer A. This is useful for summer B or C, or so on, or whatever. So again, I just want you to show you how the addendum is set up here. Is that you look at these sections that are covered. So this goes from 1, 1, 1, 2, 1, 3, 4, and 5, chapter 1, and there's been some videos out on those already. And then I'm going to talk about this part here, 2, 1, 2, 2, 2, 3, and 2, 4, and 2, 5. Okay, so chapter 2 has to deal with things like fractions and decimals and percents, scientific notation, significant difference, use of percentages in statistics. And this is mostly review, but some of you may not be used to the different calculator that you're using. Some of you bought the TI-84 or the 36X Pro, and they're better now than they used to be at dealing with these types of basic arithmetic operations. And so I'm just going to kind of briefly go over some of that stuff. And so let's go ahead and put this down again. This material right here, chapter 1 and 2, all these sections would be on the first exam. And then the next chapters 3 and 4, then those would be on the exam 2, and so on. Again, ignore these dates, right? Don't worry about those dates over there. Just 5 and 6, exam 3, and then 7 and 8 for the end. So, okay. So we're in chapter 2, and we're going to look at our e-text, and I'm just going to kind of, again, go down some of these things and assume that you've seen all this before. So a lot of this is just review in terms of the topic, but the calculator might be different for you. So um, I'm going to be using this TI-84 plus CE. So this is the most recent calculator TI has come out with for education, and it's a very good one, and it's the one that we recommend. So now fractions. So uh, you know we can write one number and then a bar over another one, and then here's the terms numerator and denominator and so on. And so we have a comparison of two numbers by division, right? It's an operation of division, and uh, a lot of times you run into fractions in statistics, and you may want to rewrite them or reduce them or add them or subtract them and so on. And so you should have some basic knowledge. But in this course in statistics, we don't care how you do them. You don't have to work out arithmetic by hand. We wouldn't really expect you to do that. You should be able to use technology to do any of the basic stuff. So let's look at here. And the first thing they talk about is equivalent fractions. And that means that two things that look different but represent the same thing. So for example, 1/3 and 2/6 are equivalent fractions, because if you take 1/3 times a form of 1, 2 divided by 2 is a form of 1. So it's like taking 1 times 1/3, right? You multiply the numerators. 2 times 1 is 2. 2 times 3 is 6. And That tells us then that 1/3 and 2/6, even though they look different, they represent the same amount. Okay. Now, if you want to reduce something in the simplest form, you can kind of factor out uh, forms of 1, but I'm not going to do that over here. I'm just going to take and put in 2 divided by 6 into the calculator. And again, I hit enter. Now, I get a decimal. So 2/6 is the same as 0.333 repeating. And most calculators have a button. If you go to math, and then it says convert to a fraction. So for number 1, I'm going to pick number 1. It's on number 1, highlighted here already. I'm going to hit enter. So I'm taking this answer here, converting it to a fraction. Hit enter, and then I get my 1/3. So when you convert, it reduces it for you. So that's kind of an easy way, if your calculator has that, to reduce a fraction. And again, let's go ahead and put this number in. So I'm going to clear this and put in 42 divided by 28. Again, I'm going to hit enter and see what happens. Okay, I get 1.5. And there's nothing wrong with that. There's nothing wrong with 1.5. But let's say we wanted to have it as a fraction. We can do math, convert to a fraction. Okay, it's already there. So we're going to hit enter and enter. And we get 3/2. Okay. So that's one thing that your calculator will do with fractions. And if you have a fraction, let's go into math and say convert it to a decimal. Whoops, let's go down to convert it to a decimal. And then it converts it back over. So it seems like we can go pretty easily back and forth from fractions to decimals. I'm going to clear this out. And it says find the sum of 7/12 and 2/12. Well, one thing you can do is, even if you don't have the fancy calculator, okay, you can use parentheses. Make sure you use parentheses. I'm going to put parentheses 7 divided by 12. That's representing my 1 fraction here. And then 2 divided by 12. So we're going to add the plus. Whoops. I keep wanting to use my keyboard. And I got to use this thing over here. Plus 2 divided by 12. Hit enter. And I get 0.75. And I can convert math to a fraction. Enter, enter. 3/4. Okay, which is what they came up with over here. So that works with addition, subtraction, multiplication, or division. It doesn't matter if you have like terms, and I'm not going to get into, denominators have to be the same to add. We really don't have to do that with the calculator. This is showing you take 5/12 to convert it to 48ths, and you convert this, you take 20 48ths plus 15 48ths and get 35. Okay, well, that's the way we used to. But with a calculator, again, we can just take parentheses 5 divided by 12. Okay, this first number, 5 divided by 12, parentheses. So there, I close that out. I'm going to add it to parentheses 5/16. So I got 5/12 plus 5/16. Enter, and I get that crazy number there. And again, that's it. But they got 35/48. Let's see what we can come up with. Math, fraction. Let's convert it over to fraction, and I got 35/48. So that works out pretty good. All right, now, before I move on, I want to go back let's go back for a minute. No, let's go here to, I'm going to clear this out. 35/48, right? So math and fraction. See, this thing has a fraction key on it. And a lot of calculators do now. And what they say is you can plug these numbers in. Oh, there they are. You can plug these numbers in. Numerator divided by denominator. Okay. Fraction of decimal. We can do all kind of stuff here. So let's see what we got there. Numerator divided by denominator. Enter. It gives you a little symbol there, and it shows you can put in 5 divided by 12. Okay. And then plus, shift plus, and then math, fraction, enter. I'm going to put in 5 divided by 16. 5, go down and put in 16. I'm going to move over there. Okay, so it kind of looks a lot nicer. We really did that before when we were putting parentheses around them. But this kind of looks nicer. Enter, and it gives you a fraction as an answer. You don't have to get the decimal and then convert it. It knows you started with fraction, so it's going to give you that as fraction. So that's a nice function. And again, subtraction, multiplication works the same. Now, one thing, you can even do division without having to remember that division is the same as multiplying by the reciprocal. So if some of you remember, when you would divide 4/5 divided by 3/10, you'd have to write it as 4/5 times, flip this, and make it 4/5 times 10/3. But you don't have to do that with the calculator. You can just put it in as is. And you could go, I'll do one more of these, math, fraction. I'm going to do 4/5, 4 divided by 5. And then see it's showing divided by. And then we've got 3 divided by 10. So I need math. Oops. Number 1. And 3 divided by 10. So 3 divided by 10. And I'm going to get out of the way there. 4/5 divided by 3/10. And I should get 8/3, right? That's what we got, 8/3. Or 2 and 2/3. We don't work with mixed numbers in statistics. That's about the least thing that we really ever deal with. You can work with mixed numbers under fraction. Let's go to math. And again, I'm not going to show every single thing this calculator does. I mean, it's lots and lots of things. But I want you to know that it's there and how to get to it. And you can play around with it and figure it out pretty easily. So this mixed numbers, this is an improper fraction. You can change those and mixed numbers. So let's go ahead and continue on. And again, you can play around with these. So decimals, there's not a whole lot from one calculator to another when working with decimals. They're the easiest thing to work with. And that's kind of what we do in statistics. We work with decimals. We like working with decimals. We don't need the complications of the way fractions are written or so on. And they're not necessary. Right? So not that we don't ever see them, or maybe data is collected and you don't know what you're going to get sometimes, and maybe people had supplied you with decimals. or fractions or mixed numbers or so on, and that could be percentages, and so you have to kind of be familiar with all of them and how to use your calculator to do that. But um, we're going to clear, okay, clear that out. And so decimals, if you're multiplying, adding, subtracting, dividing, you just put them in as is, and be careful uh, that you use parentheses if you're not sure. And just a reminder here, this writing in words 2 and 19, right? 19 thousandths, and you could write it like that. Again, we really don't deal with this in statistics. We don't write the numbers. Rounding, you do need to be able to round. Now your calculator has a mode, so if you want to always round, if you know you're going to be rounding to say 2 decimal places or something, if you go in here to mode, and you can see there's a normal, which is what we've been using. Scientific notation is a different way to show. I'll show a little bit later. And then engineering notation. Now, floating point means it just goes out whatever it's working with. But you can round it to 0, 1, 2, 3, 4 decimal places. And so I'm going to go down to 2. Whoops. 2. Okay. Enter. And let's clear this out and put in some decimals. 2.345, and then again, I'm using my keyboard, and I'm so used to doing that. Oh, clear that. 2.345. There we go. Times, and then 5.7. So I wanted to get some different. There was what? This had 3 decimal places. This had 4 decimal places. I multiplied them. But you notice I changed in my mode how many decimal places I wanted to go to, and there it rounded to 2 decimal places. Okay, so you can control that, and I would say in statistics, we typically do set it maybe 2, 3, or 4, depends on what we're working with, but a lot of times students like that because they don't have 5 or 6 or 8 or 10 decimal values after that, and gets a little confusing sometimes. So let's go back to mode. I'm going to change mine back. I'm going to go to floating and hit enter. Okay, so it'll change. So clear, enter, clear, and clear. And again, I'm going to just bypass the subtraction. And again, the long division, right? We really don't do that. If you're out of practice and you want to practice some of these doing that, but anything that's on the exam, you can use your calculator for. So I wouldn't expect you to do any of the problems out by hand. You want to practice learning to use the calculator. If I had an emulator here for the TI-36X Pro, I would also go to that, but I don't. This is the only one I have that I can do a video on. So you'll have to go online. If you have the TI-36X Pro, make sure that you go to YouTube. There's a lot of videos on how to use that. I again don't have any links other than what's on you may have another calculator, and if you go online, be surprised how many videos there are that help you use that calculator. And now percents we do work with. So here it says change each percent to a fraction or mixed number or so on. But Just a quick reminder. Again, this should be review. Percent means per 100, so it's like 75 divided by 100. When you say 75%, you're saying 75 divided by 100. So that's the fraction version of that. If you say 4%, that's 4 per 100, or 4 divided by 100. And then you can put it in your calculator. Let's say that you're thinking, wow, that's pretty easy. 75, oops, there's again my 75% means 75 divided by 100. And then I need to reduce that. I hit enter. Oh, there's it is reduced as a percentage, 0.75 if you want it to be a fraction. Then we're back to changing that over to a fraction, right? And then 3/4. So percents, again, pretty easy to deal with if you have something written as a percent. Just put it over 100 in your calculator, hit enter, it'll reduce it, or you can change it over to a fraction. So that's pretty easy. And then going back the other way, each decimal to percent, you write it out as you would read it. So this is 0.31 is 31 hundredths, and we know that hundredths means percent. So that means that is 31%. 0.31, 31 hundredths. Again, this is 5 hundredths, which means 5 100ths just means 5%. Okay, and the decimals here, you're really basically what people say is, I'll move this over 2 places and then put a percent sign in. And yes, you can do that. You could take this decimal, move it over 1, 2, and put in a percent sign and get 1.45%. Take this decimal, move it over 1, 2, and get 1.48%, and so on. And then how do you change fractions to percents? Change them to decimals. So for example, if it's clear, let's do this one, 3/8. So I'm going to put in 3 divided by 8, hit enter. There's my decimal, right? And then I could move this over and say that's 37.5%. Okay. So the calculator is very useful, even in arithmetic. I would suggest just getting very familiar. Scientific notation, and this is we're gonna just go to the calculator, and it's because this calculator is a little different, and we don't write stuff like this in statistics. You can. We don't typically with technology. It's even shorter hand than this. We think of taking scientific notation is a way to write big numbers in shorthand. And it's true. I could take this whole big number here and write it, right, like this. And you think, well, still it's kind of messy. Like this big long number here, I can write it like this. So it's kind of shortening it up. That's all scientific notation is shorthand notation. Okay. Same with exponents. If you look here, 1, and look at how big that number is. It's got 15 zeros. So we could just write it as 10 to the 15th, or 1 times 10 to the 15th. But the calculator, what I want to show you is this. Let's clear this out. The calculator has its own, so the TID4 has, so I'm going to take 1.20035 times 0.00048 and get this thing here. Look at. So this is a bunch of zeros and some numbers, and then the calculator, what it does is it says, I'm going to write this so I have it in significant digits. I can adjust this however I want it, and I'm going to put this 5.7 here without any zeros in front of it. Because if we took this number right here and wrote it out, this e to the negative 4, okay, that's really means times 10 to the negative 4. So it's taking this times 10 out and replacing it with an e. Now, what that means is I got to move this over 1, 2, 3, 4, or 0.00057616 So this right here is shorthand for this. Even though it doesn't look like it's much shorter, that's the way the calculator does it. Okay. E, this e to the negative. Negative means move the decimal point to the left. If it was e to the positive 4, we would have moved the decimal point to the right. Let's say 45,623,00 times 78555560000. Enter. This is a big number. In fact, it's got a lot of places, right? So what it does is it says, okay, I'm going to take 3.5 e to the 16, meaning I'd have to move this over 16 places to the right. Take the decimal point, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'll have to keep going and go in 16 places, add a bunch of zeros in. Or I could just write this. So again, you can work with significant digits. You can, it depends on what you're using, but we do use that function in statistics. We will see this e in statistics, so we got to understand what that means. Okay. Okay. And really, there's not much else in the chapter for you to go through and look at. And we have really using percentages in statistics was the last section here. And percentages, again, we've already talked about. We have percents, fractions, right? We can write like this, percent, we can write it as decimals. Again, you're going to use your calculator. The one thing different about section 2.5 is this idea of absolute change and relative change. The big key, it can get very confusing with percent increase, percent decrease, absolute change, relative change. Okay. So the best way to think about this is that when they say absolute, they mean just use the numbers as they are. If you're talking about dollars, and I want to know how much change there was in dollars from making $7 an hour to making $10 an hour. Okay. So let's say I go from making $7 an hour to making $10 an hour. What was my absolute change? Well, what I mean is I want to know in terms of dollars. So I take 10 minus 7 and get 3, right? So that should make sense. It's just what you would normally think of when looking at the difference in the unit of measure that you're dealing with. If one car gets 30 miles to the gallon and the other car gets 35 miles to the gallon and you buy the new one, you know, how much absolute change was there? Well, 35 minus 30, you got 5, right? You got 5, you're getting 5 more miles to the gallon. So, okay, pretty obvious, I think. But anytime you see the term relative, we're talking about percent. It could be percent change or percent increase, percent decrease. So those are confusing. You have to be careful. Relative change, okay, you'll notice here they say times 100%, because you're not just subtracting two. When you subtract two numbers, you're saying how far apart are those numbers. Okay, that's what you're doing. When you say 35 minus 30, I'm saying how far apart are the two numbers, 35 and 30? Well, they're 5 units apart, right? Now, what we can do then is take that how far apart those numbers are and then divide by one of those numbers. And that's where the confusing part's, because you got to remember, if you're looking at percent increase or percent decrease, then you got to remember which one was the original amount, okay? So let me just move this thing over here. Let's say that I do have two numbers. I start at 30, okay? So I'm going to say 30 miles to the gallon, right? And it's going to go up to 35 miles to the gallon. Right? Well, that's an increase. That's percent increase. I'm talking about percent increase, okay? So percent increase is the amount of increase, which in this case, the amount of increase is 5, right? Divided by the original amount, where you started at. You went from 30 up to 35, so percent increase is not 5 divided by 35. It's 5 divided by 30, where you started at, right? And then, again, you can go to, whoops, let me find my calculator. And you could say, okay, well, that's 5 divided by 30, right? It's about 16.16, rounding up to 7. We can even say that's roughly 17%, right? So we could even either go out a decimal. We could say approximately 16.7%. Oops. 16.7% increase in gas mileage when you go from 30 to 35. Remember, the absolute increase is 5 from here to here. That's that one. When you take your absolute increase or decrease and then you divide by one of the amounts, then you get percent of increase, percent of decrease, right? So, and okay, so I'm not going to talk about that anymore a lot again. Let's go back to this, bring this over here. All right. Now, let's look at this. This says relative change is new value minus reference value. All right, so same thing, you're subtracting the two numbers. Divided by the referenced value, right? Which in this case is the second number. They're saying that the second number, right? Now, let's look down here at this world population. Estimate world population in 1950 was 2.6 billion. By the end of 2010, it had reached 6.9 billion. So from 2.6 to 6.9. Now, how much, right, absolute change was there? How much absolute change was there from 2.6 to 6.9? All right, so they're saying subtract those two numbers. 6.9 minus 2.6 is 4.3 billion. That's my absolute change. Well, what's my relative change? They're not asking for percent of increase, right? My relative change, they say, because if we did relative change, we would have went from 4.3 divided by the 2.6. That's not what they're doing. Well, actually, I'm sorry. They are taking they switch these around. The new value minus the reference value, all divided by the reference value. And they got this absolute change of 4.3 divided by the amount. So they are calling this percent of increase, And this is the key right here that they're talking about when using percentages for comparisons. The reference value is the number that we are using as the basis for the comparison. Okay. The compared value is, on the other hand, which we compare to the reference value. So we got to be careful. When it says even in here as he talks in it, and he says that this can be very confusing. So I try to give you like one problem on the test, one very simple percent of increase or so, and but we'll come back to this later in the course. So here's our definition. And that is finally, that's really all we're going to talk about then in chapter 2. And that should complete everything for that first unit again for the 1001.